the video. This is on day 2 of the packet. In case you had any questions, maybe this will clarify it. It says number 1. Greg has a set of dice and rolls a coin. What is the probability that Greg will roll a odd number on each one? So remember, in this die, you gotta remember how many odd numbers are there. Well, these are your odd numbers. The odd numbers are 1, 3, 5. Your evens are 2, 4, and 6 on a 6-sided die. So on the first die, how many of those are odds? Well, 1, 3, 5. That means 3 of them are odd. Well, how many total sides? Well, there's 6 sides. Well, in this dice, another 6-sided die, the same thing. How many of those are odds? Well, 3 of them are odds, and there's 6 total sides. So what is the probability that Greg will roll an odd number on each die? Well, this one die, this is 2 die. You want to know what is the probability of rolling an odd number on each one? All you have to do is multiply both probabilities. And so in this case, you multiply across, left to right. So this is the way you multiply, this way. Now think, can I make these smaller? Can I make the fractions smaller? And you can simplify them. And then multiply. Think about that. Number 2. Okay, Martha has a bag of 10 marbles with 6 blue, 3 red, and 1 green. But she lost one. What is the probability that the bag now contains only blue and red? So blue and red means plus. So how many blue and red are there? Well, there's 6 blues and there's 3 reds. How many total marbles? There's 10 marbles. So 10. 6 blue, 3 red. 6 plus 3 is 9. 9 out of 10 are blue and red. Well then, how many are red? Number 3 there. Below is a bar graph of the time Frank spent doing 4 different activities last week. What is the probability that Frank was swimming in any given minute during the his exercise activities last week? So first of all, I would put numbers here. Like running, he did 10 hours. Rowing, he did 25 hours. Hiking, he did 5 hours. Swimming, he did 20 hours. And now I know my for each one, total for each one. Another good thing is to find, okay, what's the total for all of them together? 20 plus 5 is 25. 25 plus 25 is 50. Plus 10 is 60. So 60 is my total hours. That's the total hours he spent exercising. It says, what is the probability that Frank was swimming? Well, how many hours did he swim? He swam 20 hours. We got to do simplify it, and we get your answer. Number 4. James and Sarah conduct a test to compare experimental probability and theoretical probability. There is a coin. Below is a chart of their results for 10 flips. Which of the following is a true statement based on the results? Remember, experimental is when you see the word flip, toss, anything that you do work. Theoretical, this word theoretical, something just by looking. For example, if I look at a coin, any coin, a quarter has 2 sides. It has heads or tails. So theoretically, by looking at a coin, what are the chances of landing on heads? So the probability of landing on heads, a coin has 1 out of 2 because there's 2 sides. That's the theoretical. So theoretical is 1 out of 2. And so now you think that, okay, the experimental is how many times did they toss it? They tossed it 10 times. So out of 10 times, how many times did they land on heads? So how many times did they land on heads? Look, I count them. 1, 2, 3, 4. 4 times on heads. How many times did they land on tails? Well, they did 10 tosses and 4 landed on heads. That means 6 landed on tails. 6 out of 10. Okay. So now you got to compare. Now maybe you can simplify these fractions. compare. Now you can read the statements, each one. These are the experimentals. Okay, these are experimental probability. This is a theoretical. It's up to here. This is experimental. This is a theoretical. Compare both and see which one makes sense. Number 5. Quentin flipped a coin and rolled it down. What is the probability that he will flip tails and roll it down? Well, here, what's the chance of landing on tails? So the probability of landing on tails is equal to 1 out of 2 because it only has 2 sides and 1's tail. The probability of landing on the number 2 here, well, it has 6 sides. So 6 total sides. How many 2's are there? There's only 1. 1 out of 6. So what I'm going to do with those? I'm going to multiply from left to right. You get your Kai hears that tonight's meteor shower should produce 20 meters per hour. If she looks at the night sky during the meteor shower for 1 minute, what is the probability that she will see a meteor? So the probability she'll see a meteor in the first minute. So a meteor. Well, how many minutes in an hour? There's 1 hour is equal to 60 minutes. So then, what is the probability she will see a meteor? Okay. In 1 minute. So 20 meteors per hour. So then that means in 60 minutes, how many meteors can she see? She can see 20. How many can she see in 1 minute? 7. A donut shop has the following donuts left on the rack. If Karen randomly selects one donut, what is the probability that it will be a maple glaze? So what's the probability of maple glaze? Well, first of all, what's the total donuts? There's 3, 6, there's 5 here, 4, 3. So that's what? 6, 11, 15 is 18. 18 total. Okay. So how many of those are maple glaze? There's 1, 2, 3, 4 maple glaze. All you gotta do is simplify the fraction. Using the same information in question 7, what is the probability that Rebecca will also randomly choose a chocolate glaze donut after Karen? So that means that Karen has taken 1 donut already. So after Karen, how many are chocolate glazed? So let's put that to the column. Chocolate glaze. Chocolate glaze, there's 1, 2, 3, 4, 5 chocolate glaze. That means I have 5. Well, how many total? Remember, on column 7, Kaden took 1. She's going to take a maple glaze. So then that means if she took 1, how many are left for, who's this other person's name? Rebecca. How many are left for Rebecca to choose from? There's 5 available, but how many total donuts? I'll look to number 9. Because I need to take into the list that we have. There's a time. It says there, create a chart that shows all the possible outcomes of choosing black, gray, or white marble from cup 1 and black, gray, or white square from cup 2. So what you're going to do is, okay, cup 1 and cup 2. So let's see here. Well, I can choose a black circle. So I put here. Choose a black circle. Okay. I'm going to use that. I can use the black circle here. I can also have a black circle, and I can choose a black square over here. That's one combination. I can also choose a gray circle. Well, let me continue with black. I can choose black, and I can also choose the same black one, this one, but then I'm going to not choose black no more because I look at it here. I can choose gray. I can choose a gray circle, a gray square. I can choose black again, and I can choose the white one, the white That's the first one. Now, I can also choose a gray circle here. I can choose a gray circle. And I can choose a black square. I can choose the same gray circle as the first one. And I can choose a I can choose a gray square. And then I can choose a white circle. I'm sorry, the same gray circle in the first one. And I can choose the white square. So all you gotta do is find all the combinations. Okay? There's of course 2 more combinations. Because remember, we already used this black one here. We used this one here. We used the next one here. So that means you got 2 left. You gotta use the combinations here. So think about it. Once you get all the totals, then you can find these answers. But you gotta do each one. You gotta do each combination. Okay? Black is this one. So this one actually went to this guy. It also went to that guy. It also went to that guy. That's the combination. These 3 here. And this one, the same thing. He went to that guy, he went to that guy, and he went to that guy. So there's these here. You gotta find all the total combinations. Once you find each total combination, then you can answer these questions. Alright, hopefully it's helped you. Adios.